you so much, Nancy. I am excited to welcome our next speaker, Malte Jung, who comes to us from as a professor at Cornell, who leverages his very interdisciplinary background to study how robots collaborate in teams.
Don't present it side. Okay, awesome. Thank you. Okay, yeah, I changed the title to Teamwork with Machines because I wanted to talk about two studies that we just published and that don't technically involve robots. And then I added a little question mark behind the with, because I think there's some ambiguity and really open question about how we think about that configuration between sort of machines and teams. And I want to come back to that little question mark at the end. But I want to start with something different. I'm currently on sabbatical and I'm spending a lot of that time in Vancouver, and Vancouver is full of Teslas. And a few weeks ago I was pushing my bike down the street, and then that Tesla flashes at me, and I felt so offended by this, and I was thinking kind of, what is flashing their lights at me? And look at the car, there's no one in there, but in the car you have this sort of screen coming on, the sentry system activated with that somewhat hostile looking orb, and that sort of hostile stance is not an accident. They actually originally used the image from Kubrick's HAL of that AI that killed an entire space crew until the copyright folks jumped in, and that sort of behavior really also creates, like I mean, I was offended, but in some instances other reactions. Here's a video from someone that posted this on Twitter, actually, in an appeal to Elon Musk to let him switch off that sort of system, because this is what happened. He's recorded a person that Tesla flashes at them, and then later that person kind of was then seen sort of kicking at the Tesla and destroying the charging cable. So one of the points here is that when we design these machines, every little thing matters. Just this little flash. We have to be really careful how we design that stuff. And another thing for me is that kind of, I want to talk about, broadly when we think about the design of these machines, we think about the primary user that we designed that for. I mean, in the example of the robotic surgery, these systems are designed for the surgery and they don't take account the rest of the team. Here, that car is designed for that driver owner and keeping their car safe, but then there's also people like me who are on the road and that are affected and interacting in some way by that system, and then that changes my relationship to the owner of that car. And I mean, with the theme of this workshop on networks, this is that whenever we put these systems out, we place them in these complex networks of relationships and interactions. And these machines are messing with that, and that's kind of what I'm really curious in understanding. And bringing this sort of over into the teamwork space, I want to show you a short video clip from a lab study that we did a couple of years back. And in that study, we asked two people to team up and built a tower out of wooden Jenga blocks, and they had sort of constraints to make it pretty, to make it high, to make it stable. And then they had a robot that delivers them the parts. And there was this short sort of scene that kind of I found really interesting that I want to show you. It's just 20 seconds long. And the video starts with the person on the right got the last block, and then the robot's going to pick up the next one, decides who should get it. This is always some awkward situation, and for me, always this sort of reminds me of situations like you're at a workshop, at a conference, you're walking up to someone, you're trying to shake their hand, and they don't respond, and then you have that weird vulnerable moment, and you know, hard to react to that. And this is a little bit like that here, but this
you have a middle finger.
This clip is really interesting for me, and I want to kind of take it apart a little bit and walk you through. So it really starts with this expectation that gets displayed here that she would get the next block, and then that gets disappointed and leaves her in this awkward position. And what you can see is that in that exact moment, she starts to make this really tense facial expression, like a lip, what we call a lip presser. But it's not just her who responds to that robot in that strong way. It's also the other participant. He also expresses sort of discomfort, making this sort of "oh crap, why me now" face. And at that same moment, she's starting to pull back her hand and also makes this sort of tense smile. And what then comes is what we could call like a social repair attempt by the person who got the block. Kind of there's this sort of checking in to the other, to the partner to see, are we still friends here? Are we still okay? And then that whole interaction gets sort of resolved with both people looking at each other and expressing a genuine smile. And this thing is interesting for me for several reasons. Number one is like I'm doing a lot of my work in an area called human-robot interaction, and in that field there's often kind of people make that categorical distinction between sort of the social robots like the Jibos or the Nows or the Peppers that have these human-like bodies and eyes, and then the task robots like an industrial robot arm. But here we have an industrial robot arm. It doesn't have eyes. It doesn't speak. It doesn't even make a sort of Pixar lamp-like sort of motion. It does one of the simplest things a robot has ever done: pick something up and place it somewhere else. Yet people react like very, very socially to it. It clearly has sort of takes a social role in that interaction with both participants. But what's really interesting for me is that the behavior of that machine changes the interaction and relation between the two other people. It necessitates them to check in on their relationship and to see if that's still okay. And that's kind of been sort of the core question that's been fascinating for me about how these tiny little things that machines do sort of mess that at that sort of moment-to-moment interaction level with people, and to really sort of shift the focus from the one robot, one user to these, I mean, you can call them networks. I mean, I look at small teams, but at the interaction between the people. That's the focus. And maybe I don't have to explain so much here, but why should we care about that? I mean, there's plenty examples about why these interactions people have are crucial for teams. I mean, there's of course Anita Woolley's work, who's part of the workshop, who showed that when we look at collective intelligence in teams, it's less determined by who's on the team or what their intelligence is, much more based on their interpersonal interactions people have with each other while they're working together. There's also this sort of application of Amy Edmondson's work at Google on psychological safety, where they found in a large internal study that a key predictor of performance of teams at Google wasn't their skill and expertise, but actually the sort of level of psychological safety, in essence, of the kind of whether they were able to create an environment that allowed people to have vulnerable interactions with each other. That predicted team performance better than anything else. And my own past work also looked at engineering design teams, and we found that what predicted performance in those teams better than skill was the same patterns that predict divorce in married couples. It really was a much better predictor of performance in teams. So I really think these interactions are crucial, and not just for how people feel, but really how these teams perform. And I wanted to talk about sort of two recent studies where we explored how specific machine behaviors mess with these interpersonal dynamics. And the first study I want to talk about is by my student Jung, who explored what we call machine allocation behavior. And this is really a study that came out of that the robot allocates blocks between people study. What does that do? And by machine allocation behavior, we mean sort of the overt behavior that results from machine's decision about the allocation of something of value among people. And that could be the allocation of a part that people need when they work together. But it could also be just social attention. You might kind of think of a pepper robot that sits in a store, and you're walking in with your friend, and then that machine makes a decision: who is it greeting first? Or you're in a company, and an algorithm allocates the race to you, but not the other person. And while there is a ton of work on algorithmic fairness, again, it focuses mostly on how people perceive that and what the implications on one individual. But what's I think often missing is what does it do to our relationships with others. And sort of this has kind of been the focus of Houston's work. And to study this, he built an online Tetris game that he called Co-Tetris. And in Tetris, it's a Tetris game for two people that can play at the same time, but only one person at a time has sort of control over the blocks. And so you always have an active player that has the screen in color, and an inactive one that has the screen in gray. And then we have an allocator who decides who gets to play. And this is kind of what this then looks like for participants in action. So we have a human decision maker that sort of pops up and decides you get the next turn versus you get the next turn, and then people play Tetris for a while. We can measure their score and how they interact. Yeah, and this is the AI example. It's the same thing. It's just this little picture that pops up in the middle. It's an AI, and when people sign up for the study, we have an introduction that says sort of that the decision maker will be an AI versus the human. Let's see. There's one more. Yeah, you can give this a try if you like. The game is still online. If you later want to try it out. And so in our study, we had 232 participants, and we had basically six conditions. Like we assigned participants either to a condition where the allocator was a human or an AI, but then also varied whether the allocation overall amounted to a 50-50 allocation or to one in which one person got in the end more turns than the other. And that resulted at the individual level to these six conditions. You get less, you get the same amount as your other player, you get more, and this allocation is done by a human and an AI. And these are these allocation patterns over time are on the bottom, because it's like, the interesting thing about this is not this one-shot allocation of you getting the raise. It's something that develops dynamically over time. And so what we found is that people who receive less feel treated unfairly. Not too surprising. We didn't see any differences between whether the allocation was done by a human, like perceived human, always the same thing. We just told people as a human or an AI. We did find that it affects people's relationship to each other. Getting less makes you like the other person makes you like the other person less, and that's also the same for people and AI allocation. We found one interaction effect that the type of the impact of the allocation tape on perception of dominance depended on the allocation agent. That when the allocator was human, participants' perception of dominance of their partner didn't change depending on condition. But when the allocation agent was an AI, people felt that their partner was less dominant when they got more. So they felt more empowered when they got more blocks. When we looked at it at the team level, we found that unequal allocation led to better performance than equal allocation. I mean, this can be an artifact that our unequal allocation was one person got, I think, 90% of the turns, the other 110. That just if you don't get to play much, you never really get into the game. But I think at the higher level, for me, the interesting thing is that it brings up this trade-off that also you mentioned between sort of this idea of sort of the short-term performance benefit and sort of the long-term team viability and relational impact of these systems, and how we could balance that. So this is something that Houston still keeps exploring, and he's done another study where he really figured out how would you design an algorithm that sort of optimizes for both viability and performance. But sort of another study I want to talk about is more in the space of generative AI behavior, and this is a study that my former student Jess Hohenstein ran a series of studies, but this one is the one the last one that just got published that I want to talk about. And of course everyone is familiar with ChatGPT, and there's so much discussion everywhere about how a system like that can help us improve productivity and efficiency. And what I think is sort of a little bit missing, again, is that understanding about, okay, when we use these systems, what again do they do to our interactions and relationships with others? And we started this research in 2016 when Google Allo, probably anyone knows this thing, it's a now defunct messenger that Google developed that was sort of the first that had these smart replies, these algorithmic response suggestions in there, and that got us thinking about when you have this kind of stuff in your interaction, what does it do to the way people communicate and interact and perceive each other? And again, when you look at the Smart Reply API that Google publishes on the website, it's all about efficiency. Like it says, Smart Reply helps your users respond to messages quickly and makes it easier to reply to messages on devices with limited input capability. So it's always about how the AI can help your productivity and efficiency, and doesn't talk about the other impacts of that. But the kind of questions we were then curious again are about when you're interacting with someone on a message, there's there's this aspect about how the language affects your perception of them. Someone writes great, how about you? They seem friendly. But then when you see simple language like perfect, you might wonder, are they using AI here? Is that a smart reply or not? And then you're getting these responses presented yourself, and you might think about, should I use this? Should I not? So these are all these kinds of questions we were curious about when we were digging into this. And so to do this, we built our own messenger platform online. This was at the time led by my then postdoc Dominique DiFranzo, who is now assistant professor at Lehigh University. He built us a really cool system that allowed us people to have online messengers, but we had control over the smart replies. We could decide, we had control what people see, who gets smart replies, what kind of smart replies they get, when they get them, and so that allowed us then to have a really cool research platform to study this stuff in detail. So we ran two studies with it, and the first one we had people allocated 438 participants randomly to either having a condition where they either got smart replies or they didn't get smart replies, and that effectively led to sort of four conditions at the individual level. Like no one has smart reply, both have smart reply, the one person has smart replies, or the other person has smart reply. And in the second study, we always gave both people smart replies, but we changed kind of smart replies they got. We compared the standard Google smart reply algorithm against sort of smart replies that were more positive in tone and some that were more negative in tone, and wanted to test the impact on that. So what we found is that generally people use smart replies when given the opportunity. 14%, 0.3% of the sent messages contain these smart replies in our studies, and we found it has benefits. So using this AI-generated text, we found increased communication efficiency. People sent more messages per minute when they use these smart reply, and as a consequence, or is people are seeing, or maybe the part of what we found earlier is that a lot of the smart replies generated by the Google algorithm are slightly positive in sentiment. They're more positive in sentiment than what people normally write in these interactions, and so using them leads to being perceived as more cooperative and more affiliative by others. And overall changes the conversational tone, the sentiment of the interaction to a more positive one. Even if we discount the positive tone of the smart replies themselves. But there's also social cost to using them. Once people perceive you or think that you're using smart replies, they see you as less cooperative, less affiliative, and more dominant. And in our study, we found that people are able to figure out, but only to a very small degree, whether people are using them. So these two aspects here that are coming together. And in the second study, where we changed the emotional tone of the smart replies, we found that the language of the interaction really corresponds to the language of the smart reply. So when you're giving people Google smart replies, or one's a positive tone, kind of the whole conversational tone will be more positive than if you give people smart replies with a negative tone. So if you have control over the language of the smart reply, you have to some degree control over the language that comes out in the interaction. This is also something more recently. My colleague Mona Mane published a study on opinionated language models and how they subtly shift people's opinion around. And so there's really these two processes that are interesting. There's the impact of the actual use on the interaction, and then the perceived use, and they interact in really interesting ways. This idea that sort of there is this sort of negative perception aspect to using these systems is sort of not just to our studies. There's in a recent John Oliver episode, he talks about the sort of implications of people using that kind of language, and when people learn about that.
Officials at Vanderbilt University recently apologized for using ChatGPT to craft a consoling email after the mass shooting at Michigan State University, which does feel a bit creepy, doesn't it?
Yeah, so that whole perception aspect is a really interesting part of it. And yeah, the Wall Street Journal has written a whole article about how managers and using those systems in their communication can really have relational repercussions. So just wrapping things up here is this sort of there's this key thing for me is that it's the really subtle things that matters. Like there's this subtle smart reply that pops up somewhere, and or just the machine kind of placing one block here versus there, or yeah, that Tesla just flashing its lights, and all these things have these sort of ripple effects that go much deeper. And then there's this idea of that, yeah, machine support, like when we think about efficiency, effectiveness, productivity, really, there are often these social costs that come with it that we need to understand. And from a lot of the work that we've done, we can see is that often the behavior that machines exhibits often undermines the very dynamics that these teams rely on to perform. And we've seen this with these tools, we've seen this with robots. We've actually also spent years studying robotic surgery teams. We've seen that machine undermines also the very dynamics that these teams rely upon. And maybe a last thing I want to kind of, it's more this question I want to end with that brings it to this question mark is this about like, yeah, how do we theorize the role of these systems within work groups and teams? Because I think right now there is sort of, I see this whole literature of human AI, human robot, human machine, whatever teaming is sort of exploding right now. And I think a lot of that work sort of is often grounded in an idea of human robot teams like this one. Sort of that we have this sort of machine teammate that's part of the group, and I mean I'm guilty as charged. I've done some of that stuff too. This is actually a DALL-E generated image, so in collaboration with AI. But I think there's risk to that because I think if we apply that sort of theory of human teams to really kind of to these human machine configurations, number one, I think we're more likely to interpret our findings or in ways that we miss what's actually going on. I think number two is I think we're missing out on all these other ways that AI might be integrated in teams. Like I mean, here's this smart reply is part of many teams already. It's part of team communication, but no one would think that teammate would be the right way to conceptualize this. I mean, in your work too, it's so much more complex in that scenario that you showed than just that teammate. But also from a design side, I think this idea of building robot teammates, even many papers start with this idea. In the future, we'll have those, but I'm very skeptical that that's where it's going. I mean, back in the 90s, I think our kind of often that narrative of robot teammates in many of the studies often aligns well with sort of we've seen in movies in the 90s. Like this one is from Arnold Schwarzenegger, the movie. Of a robot taxi driver. Yeah, the robot driving the car.
You're in a Johnny Cat.
I mean, what am I doing here?
But this is not what we have now. We have a Tesla. We don't want like that space being taken up by a human or robot. It sits there, drives our car, and has all the limitations that we have in understanding the situation. It makes much more sense that the car itself is the robot and can access all the sensor. Or I mean, similarly, we don't want to buy a $30,000 Tesla Prime, whatever it's called, robot to operate our CD player at home. Like we can do that with a $30 smart speaker much more easily. And so I think kind of even from a design perspective, there's a huge question about to what degree that kind of humanoid notion of a machine teammate makes sense. And yeah, with that, I'll stop. Thank you. Yes.
You don't have to go all the way to robots to see how it affects, to smart reply, to see how technology affects people communication. People observed decades ago that a face-to-face conversation versus email conversations are already completely different.
Yeah. Yeah, no, all these impacts are really different. I think for me, what's often with robots is so interesting where we started is kind of this aspect how the physical behavior matters, and I think over a lot of our online or traditional human-machine interaction, what's so interesting is about often robots is that the behavior is not, the interaction is not discrete. Kind of these machines continuously move, so the behavior is continuous, the interaction is continuous. So there's some interesting differences. It's interesting to see where they are, and Lionel, and then Liz, and then
Yeah. So one of the things I noticed about this, when Google has this thing when you email it would suggest replies for you, right?
yeah,
And I assume when they first started doing that, it used my prior data to determine it, right?
Yeah.
And so I would, when it would suggest, I would look down and determine if I wanted to use a suggestion and which one. But now I feel like it's leading me. And so there are cases now where I'm brain dead, I got to reply. And so it's like, it's not if I'm going to use it, it's which one am I going to use. And in many cases, it's not really me. Like, I know this is not something I would say, but I don't really care because I'm brain dead. I'm going to send it anyway, right? And so there's some point where basically, my language, I suspect, is beginning to change. Like, it's beginning to lead me. Where maybe in the beginning, I sort of led it to what it would suggest. Now it seems to be kind of leading me to use maybe different language in ways that I wouldn't use before. But I'm just so tired, answering email. I don't really care. So I don't know if you have sort of paid attention to like those long-term effects of this interaction.
I mean, this was a short term, but I mean, this raised exactly those questions. I mean, even going earlier to us, how these language models are trained, right? There is a certain data set with sort of certain biases for what kind of language we see, and then we suggest that language to anyone else. So does that mean we lose diversity in language and expression and how people write with it? So there's a ton of really interesting questions long term. I mean, for us, the key question here at this time when we started in 2016 was just even how do we get data? At the beginning, there was no API, so we ran our first study in the lab installing Google Allo on a phone and letting people use the phone in a lab study and then wiping the phone after each participant so that whatever they did earlier didn't inform the next one. But it was so tedious that we got just a tiny data set, and then it was too small to see any effects. And then later, it led to, the tricky part is that I think it'll be fascinating to dig into this. And then Liz, and then.
Thanks, this was great. Always fun to see your work. I wonder if instead of thinking about this as human-machine interaction, we think about it as human-machine integration.
Mm-hmm.
So that is like thinking on a perspective of to what extent our machines are already integrated into our body, perhaps a pacemaker, whatever, right? Where we don't even, it's so ingrained in who we are. To then going out and farther out. So I think you're right. I think the paradigm is not right. Just saying, how are we? Let's just make humanoid robots. So I think I like the idea of integration. To what extent are computers integrated?
Yeah, I mean, we've seen different. I mean, there's this question we kind of thought about integration. Sometimes we also thought like there's this augmentation aspect that comes in. We've explored studies where we kind of thought of machines as social catalysts, where we thought, what if a machine can just not try to help the team in any way on all the tasks, but what if it can just nudge these teams to develop better social routines or interactions? And there's so many different ways, and kind of I see it more like in how many ways
space,
can you
right?
understand?
Like how much agency do you give? How much is it integrated?
Yeah.
There's a whole mapping rather than just
and it's a fascinating space. I mean, also kind of just the design space is interesting to not sort of be constrained by that. How do I make the team kind of made happen? But really, like, what are the broader options that there are? Yeah, Paul.
Yeah, so I just wonder how maybe some of your results might differ or change if the framing were a little bit different. So, like, let's say individuals were told that instead of this being AI, it's kind of the evolution of the spell checker to Grammarly to now that, right? Would there be some, because, people don't get upset with spell checkers, right? And in some sense, there is this natural evolution in terms of how these systems work. And you think that if that if it was kind of reframed in terms of what this thing is doing or how it's evolved, that some of these results would change?
I'm pretty sure the results would change based on how the AI is framed. I mean, we ran Jung Ho, one of my PhD students, ran a study a few years back, looking at sort of the whole sort of trying to at the literature of algorithmic appreciation aversion. You always have this. Some studies say come to the conclusion, algorithmic aversion, some appreciation. He found like, if you use the same scenario, just change the framing, you can get one or the other just based on how you frame the AI. So yeah, I would absolutely think that would affect things. Yeah, there was a question first.
Yeah. I was curious about the degree to which you see where the intelligence is located. So an example of the Tesla, you can have a robot that you designed that was smart enough to get in and drive the Tesla.
Yeah.
But the Tesla can be smart enough on its own to drive itself.
Yeah.
So how do you see the role of the robot relative to the object that's being done, if it's possible to put the intelligence into the object?
Yeah.
And how does that play off? How does it make it change the way you think about what the object is and what it's doing?
Yeah, that's a fascinating question, sort of where the intelligence is located. There's I mean, we came across that initially that sort of question when we ran the first version of that robot with the block building study. Our first study design was that we wanted to have a human and a robot condition. So we told people that I think in one condition that there is another person controlling the robot versus an AI. So we separated the AI from the machine. But I actually forgot. We noticed people. Something in our study didn't work, and we kind of decided let's make it simpler and just focus on the robot and let people conceptualize that the robot's making decision. And it really had an impact on the interaction. I mean, there is at CMU there is C. Tan, I think, and Michal Luria and some others have done some studies about sort of different robot bodies when there are sort of AI switches between bodies, how people perceive that. There's some really cool work there. But I could dig it out. But yeah, that's a fascinating question.
Thank you very much. This is really interesting, and thank you for including an industrial robot and showing the social reaction, because I think that is one of the large spots we're not paying attention to. You know, we focus so much on social robotics and robots that actually, or AI systems that speak in verbal terms, but just how we as humans automatically exist within the social space. And so as someone who's in human-machine communication, I think you were asking about, thinking about theories and ways at this. When I say human-machine communication, I know a lot of people think of more of it as like message production and sending a message. That's not what communication research is. We look at socially situated and thinking about these machines as social others, and going back and kind of trying to piece through in time about that. And so that's what I find is so exciting about what you're doing. But I'd also be interested to kind of see in the long term where this is going to go, because in my own research, and one thing we look at are perceptions of artificial intelligence, and how they've previously been informed by what's called the Hollywood syndrome, right? Well, now we're seeing that Alexa and other interactions are starting to play a role. So I'll be really interested to see what kind of comes next with this as people start to integrate AI into their domestic spaces and then bring that knowledge into the workspaces. And I don't know if you've looked at that at all. But
what comes next? How can you say a bit more what you mean?
So in other words, I mean, thinking about the fact that a lot of times when we look at robots, and we've been studying robots in working groups, We're in a very specific context, but not this. And I've been seeing this a lot in a lot of reviews I've been doing. People are asking questions about, like, have you interacted with Siri? Have you interacted with Alexa? Have you interacted, like, because we know that knowledge of other technologies informs perceptions of. And so that's what I'm just saying, in the future, and this is a large challenge for all of us, but how do we connect all those perceptions together?
Good question. I mean, short answer is I don't know. It's really interesting. I mean, in some ways, I think that sort of knowledge informs things. I mean, like, as we know that these smart replies and that stuff exist, we change our perceptions of others and suspect people to use this stuff, and then and sort of that's sort of a whole cultural question about how that'll sort itself out, like how it'll become okay to use it and when, and because it won't go away. And on the other hand, there are these things about that we've noticed that in some way the knowledge also doesn't matter. Like the first human-robot interaction study that I did was some sort of also teamwork with two autonomous robots and a person, and we did it together with Cynthia Brazil's group at the MIT Media Lab, and we ran it there. So and all of the participants were sort of engineering students and roboticists, and sort of like kind of there. Sort of above it all, they know what this machine is doing, but no, they once in the situation, it didn't matter if you're a roboticist or not. You react to these machines in the same way. So there's two aspects of that. And Nancy, and then you.
I'll follow on. So years ago, we did a study in which there were 3 people interacting as a team to fly a manned aerial vehicle, and we told the one group, we said, you're interacting with an AI, which was in a different realm, but it was really just another participant. And people who were told they were interacting with an AI treated that poor person much differently. They gave it more commands, and they kept it out of the loop in many cases. I think that the perception issue is really important because, and I sense too that there's a generational difference in how younger people are perceiving AI and robots versus older folk.
Yeah, what you're mentioning about the sort of AI being mistreated, that's something like Lindsay ran a huge study that I was part of, and in that kind of we saw that too about the AI. Even if it has the same abilities, then exactly the same, even interaction capabilities like a human member, it gets bullied and mistreated. It's a really, really categorical difference, which is really fascinating. And then Matthew, and then
this is a super awesome presentation. I'm kind of curious on your perspective of how the goal plays a role in the industrial robot or the code Tetris kind of play, or basically, was it about performance and people getting the highest score in Tetris, or like building the highest whatever blocks, or was it about having fun while doing so? Because I could see very different kind of responses by people and whatnot, and so kind of curious on your thoughts on how different goals for teams.
I think they were more performance framed in both, and I'm pretty sure you would get like the framing would change. I mean, there is like Lee Ross, Mark Lepper's the name of the game, or was it Lee Ross's the name of the game study? I could show that the whole task changes dramatically.
Because it's interesting thinking about like how maybe the AI is identifying the skills in one player versus the other, and of course, if one player only has 10% of the plays, maybe they never had a chance to like showcase. And so there's all these little other details of like.
I mean, in the Tetris game, I think we left the framing of we just said AI or another MTurk worker who makes the decision. We left it deliberately ambiguous to let people make up. In that block study with the robot, we told people the robot has been trained on a data set of many kind of thousands of teams playing this game, and it makes decisions based on whoever it thinks can do a better job at placing the next block. So there was sort of that idea that whatever the robot does has sort of an implicit judgment of
Because I could see like the next experiment being not just telling people that it's trying to do this, but actually building the model that does that in the best way, and then comparing against someone who's maybe effective at allocating team performance.
Yeah, that's sort of the nice thing, part of the reason why we built that Tetris game, because like the robot study that we did, it took us a year to collect a small data set of 30 teams. It's just a nightmare to run this and collect this. And that was just like, yeah, one one study, the robot allocates them equally, unequally. And then with that Tetris game, the nice thing is now it's easy to collect data, and we can do exactly what you said. We can do the study that we did. We can train an actual algorithm trying to learn people's skill at playing Tetris and weighing that against these relational aspects. And, yeah, no, that's
Just to piggyback on that, I'm curious how much you think like co-presence and embodiment might be like affecting the machine allocation task. So with respect to like co-Tetris, I wonder the impact of players being able to see the other person's reaction to unfairness and inequality. So if I'm happy, I'm getting all the opportunities. Does that affect? But then with the embodiment aspect, I think it's interesting with the animatronic kind of like a robot arm, there's like a very salient like choice being made where like in the Tetris environment, yeah, I see I'm not getting a turn, but it's not as prevalent, or even with your Tesla example where it's like flashing the horn or flashing the lights at you. So could you share more about how you think there's a relationship between like co-presence when you can perceive the other person's reaction plus the embodiment of the AI?
Yeah, I mean, the co-presence is a really interesting one. One of the ideas, we wanted to run this study again with people in the lab playing Tetris while they can see each other. I mean, one version of our online game also has sort of we thought about including a messenger so people can write each other, and we can have some additional data about like those relational dynamics rather than just having survey questions. We haven't done any
you
of
just
that.
made me think the other cool thing you could do if you could like let people give up their turn if they want to. That could be an
We actually had that in an initial version of the block study with the robot. We gave people the option sort of to hand it over because we thought like, as a TV is like, when do people do that and share the blocks? But then because there were so many moving parts, it was a new study design, a new robot, like a new measures, it got also messy. I said, okay, let's start simple. But we actually have a version of the Tetris game where to look at the interaction where while you're having the turn, I can also control the same block. And you see sort of a ghost version of that. So we thought like, when we do that, can we then see, but if I still have some degree of influence on your decision where you place, because you can see me, here's where I would place it. But again, once we used that thing, we didn't see it washed like no effects anymore, and so we thought, okay, let's just start simple. But yeah, there's a ton of things we could try, and on the question of embodiment, that's a huge question in the HRI community, what the body actually does. And there's really, I mean, there's one key finding is that once you have an embodied robot, it seems to be more persuasive than a disembodied one. There are studies that showed like a robot on the screen, same size, and one embodied. Like people follow what the physical one does and this is not. But it's unclear about why those effects are seen. There's one paper that argued that a key reason seems to be that whether the body matters when sort of the framing of the task, or what people are working on has sort of has an embodied aspect to it, a physical. So for example, if you're just doing a task that's all about negotiation and talking, then the embodiment doesn't matter. If you're doing a physical task where the robot could potentially mess with it physically, then the body matters. So that's in short a little bit what it seems to be going on. But yeah, thank you. Dan, and then, yeah.
Yeah, I mean, the embodiment might matter in a negotiation depending on how the robot uses its body language. Right? I could certainly get closer
But you could do that with
and I could raise up, right? There are things you can do.
Yeah.
But higher level question, so So I don't know how many people have gotten a sort of happy birthday from a Facebook friend recently, but I remember when that used to be a thing, and I remember how much I hated it because I kept thinking about how little effort went into it, right? And it feels like there's something about how people make inferences about the ways and reasons people are generating messages, people or robots are generating messages. That's sort of somewhere between linguistics or communication or social psychology that could really be brought to bear for thinking about some of these questions about why if I perceive somebody as using smart replies, they're less affiliative, right? It would be really useful, I think, to spend some time pulling that stuff in to help
to understand what the mechanisms are.
A set of results.
Yeah, no, that's a great, so great to really dig into what are those mechanisms. Is it about sort of this perception of, are you making a genuineness or authenticity and whatever comes in.
An effort, right? An effort. It's easy
yeah.
to hit a button that says some stupid phrase. I mean,
you see
that's not even thoughtful.
Yeah, it's really interesting when you follow. There is this famous designer in New York called Stefan Sargmeister, and he has sort of an Instagram channel where he asks people to submit their work, and then he critiques. He gives a short critique, and then over the past year or so, like more and more of the AI generated sort of stuff comes up, and then you see that the really discussions, the comments are really interesting about like all the graphic designers commenting about like, you know, what you do, pushing a button, keywords, and you can see a lot of that sort of verbalized of these suspicions about effort, and it's interesting to look at that. But yeah, you had another.
Well, I'm just looking to the next step. Both sides are using chatbots.
What sites are using?
Both sides are now going to use chatbots, right? Yeah. You're going on dating app, and now your chatbot is talking to the other side chatbot.
So I can just watch it to. Yeah, I mean, this is an interesting. I mean, there's this aspect of that I think is interesting here. Delegation about how do we do this, and when do we delegate what we do to an AI? When I had like Solas Shen, was a postdoc with me. We often joked about we wanted to do a study. We never did it about delegating sort of something blameworthy versus praiseworthy for a robot. Like you're delegating the robot. You should go to you and tell you that you're fired, or you get a raise. And then I'm wondering which robot would people pick if we gave them sort of an industrial robot versus a humanoid. And so we thought about maybe people pick the industrial robot for the message to tell you to give you a raise, because then people might project the autonomy back onto me, like this machine just executes what I told it. But if I want someone fired, maybe I pick the humanoid robot, because then people attribute agency to the machine. So there's I think some really interesting question about how that part sort of plays out. Yeah.
Your picture, your mid-journey picture of the robot. You don't have to put it back up, but the two people and the robot. Made me think about when you said this robot's a member of this team.
Yeah.
So visually, this picture makes me think of a triad.
Yeah.
Right, and this concept of triadic closure in networks, right? You know, so I'm more likely to like this person or trust this person if I like and trust the person that we're friends with, right?
Yeah.
And I'm curious, we've had all this discussion about perception, which is that if you swapped out this robot for a person, each of the other two people on the side would have a history with that person that would be making perceptions about how this person's actions are going to affect the way the other person thinks, and then affects me. If you have a sort of a zero history robot that comes into a situation, or a robot that is you're told is always going to be neutral and unbiased and unwavering, how might that affect that sort of triadic interaction in a team, do you think?
That's a really cool question. But if you're kind of interested in sort of these longitudinal effects, Lindsay, you should definitely talk. I mean, that's a big part of her dissertation work, to study kind of the machine as a newcomer and how it's perceived kind of over time. Yeah, really, that's a great questions will be a long discussion. I'm happy to chat more. Awesome. Yeah, one
I'm just kind of curious. Is there any work that looks at how much humans, when working with machines in this capacity, right? We're thinking of machines as teammates and so forth, actually attribute human qualities to the machine. I mean, mostly I just think of it as a machine. Right? Alexa is not my teammate. She keeps lists. She's a good timer. She makes lots of mistakes. I yell at her, but she's just a thing.
Yeah.
There's no human quality to it. And I think a lot, I mean, so yes, as we get more of a physical creature or machine that seems to embody more human, and maybe we start to attribute human qualities to it, like in a Star Wars movies, for example.
Yeah.
But right now, I'm not seeing that. I'm seeing things that can do some pretty sophisticated things, and so if they're helpful, I'm happy to push the button. They're not my friend, they're not my teammate.
Yeah.
Do we have any data that bears on those sort of general perceptions?
I think that there are quite some studies that do show that in some certain senses people can really perceive these systems as very human-like. I think the question is more like about when. I think it's dynamic. This is more like momentarily you get that, but then people can also step back and say, no, this is a machine. But I think in the moment you see really a lot of these. We've seen it like with the industrial robot kind of. There is this sort of moments when people respond to it socially, and I mean there are studies out of psychology that show kind of that some sort of based down to brain activity is in some cases indistinguishable what you would see when people interact with the human. When you ask people on a questionnaire, is this robot your teammate? People might even say yes, even when you then later actually look at the video, no, that doesn't look like what I would expect the teammate to look. I think it's a little bit of a matter about what perspective do you take, and it's really tricky that even the whole teammate literature, there's like Lindsay and I talked about that, there's not even a clear really definition what a teammate actually is, and so it becomes really complex that you can't just kind of have a rule-based approach and say, okay, this machine meets these criteria, it doesn't. It's really tricky. So Lindsay and I had an interesting discussion last night about like kind of it's fascinating what these machines kind of bring up and actually help us to rethink about even how we think about teams in general, what team membership means and what team is.
To this question, there's military research, right? So we know the robots that can dismantle like IEDs. And the troops become very attached to those. There have been instances in which they've asked the robots to be fixed, and they're like, "No, we'll get you a new robot." And they're like, "No, we want our robot."
And they have to be repaired.
And so it's a very contextual, but
Janet Vertesi did amazing work on the Mars rover team at NASA, and in her book on that like years-long ethnographic work, she describes this whole long funeral like they held at NASA for the Mars rover, so it's a really interesting spectrum, kind of how these things fit in, but yeah.
And I guess there's this component of how do we talk to the machine too. I just know this because with my little kids the question came up is like, do you say please and thank you to Alexa and Siri and so on, right? And I don't know if you do.
My kid won't even say thank you.
No, I'm not saying they do. Exactly. I'm the same boat, right?
Yeah, we do that at home too. But I'm sort of really skeptical about this sort of thinking about these machines as humanoid. It's in some way different, but kind of figuring out how to conceptualize that. It's a fascinating question. But yeah, we're 5 minutes.
Thank you so much. Thank you so much, Malte.